All right, 8-3 algebra, example number 1. So we looked at some of these examples in the previous lesson. These ones we just are actually going to focus on here. So again, we are identifying which ones are geometric. We're fixing my mistake because we don't want to identify the common difference, but we want to identify the common ratio instead. There. Fill in the blanks, create the equation to represent it, and find the 10th term. So let's jump right in. So from yesterday or last lesson, I remember you guys noticing that in order to get to 2 to 4, I can either add 2 or I can multiply by 2. In order to go from 4 to 8, I would have to add 4 or multiply by 2. So you can see immediately that this isn't going to be linear because it doesn't have that constant rate of change. I'm starting off by adding 2 and then adding 4, not the same, so not arithmetic, which means that this is geometric. And that's because it has that multiplying factor. What that multiplying factor is 2, right? I have to multiply by 2 to get to the next term. So 8 times 2 would give us the missing piece of 16. And then that fills the pattern. 16 times 2 is 32, and 32 times 2 is 64. So our multiplying factor, aka our common ratio, so that common ratio is that 2. Filled in the blanks. Equation, it's geometric, which means it's going to be exponential, which means it's going to be a y equals, a times b to the n. So I'm just going to do it in function notation. A of n is equal to, we know our multiplying factor is that 2 to the n. And I just need to find my y-intercept. There's nothing here in this notes that tell me that this is a sub 0, so that means I assume that that's a sub 1, which means I need to be able to work backwards like we've been practicing to find that a sub 0. So if I multiply by 2 to go forward, I would need to divide by 2 to go backwards. So I'm going to fill this in over here. A sub 0 is equal to 2 divided by 2. A sub 0 is equal to 1, which makes sense because 1 times 2 would get me to 2. So a sub 0 is 1. 1 times 2 gets me to 2. So, and for my a value is now 1. In sequence notation, that would be a sub n is equal to 1, parentheses, 2, still raised to the n power. And then the 10th term of that, of course, we can squeeze over here. A of 10 is equal to 1 times 2 to the 10th power. And if you go ahead and calculate that, you'll see that a sub 10 turns out to be 1,024. Okay, next, sequence number B, letter B. Here is a little weird because you can notice that we have a sign change going on. So that's an interesting thing. We have sign change. I start off with a negative, and then I go to a positive, and then I go to a negative, and then I go to a positive. So weird. To go from negative 60 all the way to 30, I would need to be adding 90. And then to go from 30 all the way to negative 15, I would need to be subtracting 45. So immediately I know right off the bat that this is not linear or not arithmetic. It doesn't have a common difference. So there must be something I'm multiplying by. Technically, my numbers are going down, right? I'm starting with 60 if I ignore the negatives. If I start with 60, I'm going to 30 to 15 to 7.5. And I do know that 30 is half of 60 and 15 is half of 30. And I know that 7.5 is half of 15. So that tells me that I'm doing something with 1/2. I'm dividing by 2, or like we talked about, multiplying by 1/2. So times 1/2 times 1/2. But that doesn't make up for the sign change. In order for the sign to be changing back and forth from positive to negative, it would have to be a negative 1/2. So the sign change tells you that your common ratio is negative. That's what that tells you right there. So 7.5 times negative 1/2 is going to give me negative, there we go, negative 3.75. Okay, so again, geometric, because you have a multiplying factor of negative 1/2, which again tells us that that's our common ratio. Okay, so then coming up with our equation, we've got to find that a sub 0. A sub 0 is going to be equal to negative 60, the previous term. So if I'm multiplying by 1/2 to go forward, the opposite of multiplying by 1/2 is multiplying by the reciprocal. The reciprocal of 1/2 is 2. So I'd need to multiply by negative, because the negative stays, 2. Easier to think about it, in terms of dividing. I'm dividing negative 60 by negative 2 to get to 30. I'm dividing 30 by negative 2 to get to negative 15. So the opposite of dividing by negative 2 is multiplying by negative 2 to give me an a sub 0 of positive 120, allowing me to use that in my equation. A sub 0 is equal to 120, negative 1/2 inside the parentheses, raised to the n. And then in sequence notation, if you're feeling fancy, same exact thing. Don't forget your negative. All right, last but not least here, we have part C, or sequence number C, letter C to look at. Starting with 1 and going to 1/5. Well, definitely not arithmetic, because that would involve minusing 4/5, and that's not going to continue working. So definitely geometric. Because multiplying factor. To get from 1 to 1/5, I'm taking that and dividing that by 5. Dividing by 5 is the same thing as multiplying by 1/5, which makes sense, because 1/5 times 1/5, 1 times 1 stays 1 on the top, 5 times 5 gives me 25, 25 times 5. 125 times 5 is, I'm pretty sure, 625, but let's just double check. 125 times 5, 625, keeping the 1 over the same. So geometric, because it has a multiplying factor of 1/5, which is therefore my common ratio. Okay. Oh, I forgot to find the 10th term of the other one. A of 10 would be 120. We'll just do this really quick and I'll write it down for you. And that gives you something along the lines of 718, something like that. Okay. All right. we're just going to make the equation on this one and then call it a day. So a sub n is equal to, I need my y-intercept. All right, so if I'm dividing by 5 to get to the previous one, I need to multiply by 5 to go backwards. So a sub 0 is going to be equal to 1 times 5, which would make a sub 0 5, which makes sense because 5 divided by 5 gets us to 1. So a sub n is equal to 5 times that 1/5 to the nth power, or in function notation with the parentheses instead. And we're not going to find the 10th term for this one because I said so.